Hello, welcome to PhyzQuest. This video is about the solution of JEST 2019 Part A, question number 2. So question number 2 is a DC voltage of 80 volt is switched on across a circuit containing a resistance of 5 ohm in series with an inductance of 20 Henry. What is the rate of change of current at the instant when the current is 12 ampere? Now 4 options are given and you have to choose the correct option. So this question is based on electricity and magnetism, and the concept involved here is the transient current and voltage. Why transient current and voltage? Because here the question mentions about the calculation or calculating the value at that instant. So that is what is done using transient value. So what do you mean by transient? Now transient, whenever you deal with a circuit with a voltage source along with different elements like resistor, capacitor, inductor, these term arises. Now consider this circuit. There is a voltage source V and elements inductor L and resistor R. There is a switch here. Okay. So when the voltage source is connected to the circuit after some time will attain the steady state. So steady state means after reaching the steady state, the current and the voltage become constant. But whenever you connected the voltage source for the first time in the circuit, it cannot reach the steady state at that instant. It takes its time to reach its steady state value for this voltage and the current. Now consider the other way. Suppose there is a circuit already in a steady state and you suddenly disconnect it. So what will happen in this case? When the voltage source is removed from the circuit, the steady state of the circuit will break and it will attain a new values of voltage and current. But to reach that new value, the circuit will take time. So this transition time is called the transient. So the transition process takes place when the voltage source, inductor, resistor, capacitor elements are connected or disconnected. So during that transient process, the current and voltage in the circuit are functions of time, and that's why they are called the transient current and the transient voltage. Now talking about this question, here in this question there is a voltage source, there is a resistor and there is an inductor. The voltage source has value 80 volt, inductor having value 20 Henry and resistor having value 5 ohm. So when this type of circuit is connected to the voltage source, the transient process starts and current will flow. So the current at that instant we can write using the equation V minus L di by dt is equal to Ri. Now here L di by dt is your EMF induced in the circuit at that instant due to the rate of increase of current across the inductor L. Now when you solve this equation and integrate it, because this equation is, as you can see, it's a function of current with is a function of time. So when you solve this problem or this equation for current, you have to integrate it. So after the integration you will get a relation for the current at any instant t. So after solving it, you will get the relationship like I is equal to I0 1 minus exponential of minus RT by L. Now here I0 is the steady value of the current, which is equal to V by R. This is actually the maximum value of the current. And this maximum value happens when time t is equal to infinity. Now anyway, that's a theoretical value. Practically it is smaller. Now you have to use this relationship to using the value whatever given in the question and find out the rate of change of current at that instant. So when the circuit is switched on, I is equal to V by R 1 minus exponential of minus RT by L. Now from this equation, rate of change of current you can get as di by dt is equal to V by R, and the differentiation will take place for this. So it will be minus R by L, and this differentiation will give you minus exponential of minus RT by L. Now here R and R will get cancelled. This is already a minus value, this is already a minus value. So minus minus will become plus. So ultimately you get di by dt is equal to V by L minus exponential of minus RT by L. I'm sorry, there is no minus here. This will be plus V by L exponential of minus RT by L. Now exponential of minus RT by L you can get from this equation already. See, here in this expression, if you look here, exponential of RT by L will be one minus R by B into I, because see here if you take V by R to this side, I minus V by R is equal to 1 minus exponential of minus RT by L. So exponential of minus RT by L will be equal to 1 minus R by B into I. So this we can put in this relationship. So instead of here we can use this. This will be V by L 1 minus R by B into I. Now you can just put the values given in the question. Here V is equal to 80 volt, L is 20 Henry, R is 5 ohm. So just put the value and get the answer. So just putting the values, it will be 80 by 20, that is V is 80 and L is 20. 1 minus R is 5 divided by, again V is 80, multiplied with current we need to find out at 12 amperes. So I value will be equal to 12. So this will be 12 into 5 is 60 by 80. This will be, so 1 minus 60 by 80, it will be 20 by 80. So 80 by 20 into, so this will be 20 by 80. This will be equal to 1 ampere per second. So now here this is the answer of this question, 1 ampere per second. Now this can be solvable by using an alternate approach. Now you have given the circuit, by just using the simple Kirchhoff's voltage law, you have the relationship V minus L di by dt is equal to Ri. So simply you can just find out the expression of di by dt from here, which will be V minus IR divided by L. So now just put the values of all the parameters, which will be 80 minus 12 into 5 divided by 20, again which will be 1 ampere per second. So this approach can save a lot of your time, because you can directly solve this answer. Otherwise, if you use that relationship and then you can find, it may take a bit of time. So ultimately your answer is 1 ampere per second. Now let's look at the options. Now if you look at the options here, option B is the answer we have got. So correct answer for this question is option B. Thank you.